Hello and welcome to a new video. My name is Herwig Juster and today I show you 10 considerations for polymer material selection. Okay, in general, information gathering is the start of every material selection process. And during this information gathering phase, several points need to be considered. And I collected 10 points, which I believe are important for in this information gathering phase. Okay, let's get started with the first point. First point is the costs and proper cost estimation. So we always need to seek for balance in price and performance. And most of the times there are also cost targets involved in the material selection. Can be cost per kilograms or cost per part. And important is also that a part of material costs, you have to keep in mind processing, tooling and assembling costs. And important factor is also to look at the volume and not the weight of the part. So we always have to compare the cost per volume and not cost per kilogram, because by the end we need to fill a certain part volume. So it's really important to check the densities of the selected materials. Also, a simple tool for estimating cost prices are cost factors, and it is shown here also. For example, the product P cost R equal cost factor times the material cost. And for example, when you have as a processing technique injection molding, the cost factor is between 1.2 to between 1.2 and 2. So it really depends, and those cost factors are also in the literature available. Okay, the second consideration is the environmental exposure. So I also have to think the product end use, will it be indoor, outdoor or both? And a good tool for keeping the environmental exposure in mind is the polymer environmental trinity, consisting of thermal, chemicals and time. So this is shown on the right side here, this triangle. And when we look at the temperature requirements, we always have to check what are the minimum and maximum temperature conditions, and what is the continuous use temperature, and how much is the part exposed to the extreme temperatures. Then also exposure to UV light or extreme weather conditions is important to check. And then also the chemical exposure. Is the part exposed to splash only, so you need splash resistant, or is the part fully immersed in a chemical like oil? Or and important is also to have temperature during this chemical exposure. This can also heavily impact on the polymer material. Also important, the chemical type, to find out if it is acid, base, oil, a cleaning solution or some other. And then also in combination, temperature, chemical, time and also mechanical exposure. So do we have a chemical exposure together with temperature and a load, or is this a permanent load or just repeatedly cyclic load? So this we always have to check. But the important thing is here to start with this pyramid. Then the material property data, and where to get good high quality property data of the selected materials. And in general, we have three pillars of data. We can have short-term data. It can be a tensile strength, elongation and break. Then we have a long-term data where we look willing to creep, flexural creep modulus. And then we have also cyclic data, like for fatigue performance or having the Wöhler curves. And technical data sheets are a good support for initial selection. However, it should be not the only source for selecting a material. And its technical datasheets are handy to compare the relative performance of materials to each other. And for screening a large number of different plastics, we can use online or offline databases. And I just mentioned here the campus, so the computer-aided pre-selection by uniform standards is existing over several years already, and works well in this field. Then number 4, processing data. We also have to check the manufacturing process and select for processability. And depending if we use injection molding, extrusion, thermoforming, or blow molding, we can always tailor the material to those processing techniques. Also have a look of the part design itself. It can be that there are thin or thick sections, so the selected material must be capable of properly fill also this thin or thick sections. So it's good to perform also virtual filling study, mold flow simulation, for example. But the best is to avoid such thick or extreme thin sections. And also in 2-component system, here we have to check when we have overmolded or co-extrusion onto another material, that the substrate, the base material, is known, and if the compatibility is okay between the 2 components. Then number 5, appearance. So the perceived quality of plastic parts is strongly connected with the aesthetics, and usually we have here 3 points which we can differentiate here. So we have on the one hand surface haptics, on the other hand the surface finish, and then the number 3 is the color. And when we look in house appliances and children toys, we often find ABS because it has this high gloss finish and is a tough material, and you can color it in several different combination of colors. Then, for example, when we have high-loaded, glass-loaded polyamides, they often have a blurred surface, so it's more suitable for non-visual parts. And also the coloring itself, there are certain base resins which are better for coloring, and important is to, since it is a cost factor to add color, to start with color master batches. It's the most cost-effective way to color lots of polymer resins. And also when you have several parts which build up a system of components, it is important, or it is useful to make all these components out of the same base resin if possible, especially for aesthetical critical parts. Okay, number 6, agency approvals. So we always have to check if this part and the industry we are into need some governmental or agency approvals. I've listed here several agencies. Well known is the Underwriters Laboratories at the UL, also in connection with the flame class ratings and the standard they developed, so the UL 94. We have then the Food and Drug Administration, FDA, for parts which are in contact with food or medical devices. This is mainly for North America. In Europe we have the European Medicines Agency, the EMA. Then we have military agencies when we have applications which are used for military purpose. Then we have also agricultural approval agencies, especially for packing of meat, and equipment which is used for meat processing. There's also approvals for food processing equipment and piping, which is in contact with drinking water. And there's also for example, the JEDEC for semiconductor engineering. Okay, then we continue with industry specifications. Here also I've listed different industry, starting with automotive. As you can see, we have IATF, we have IMDS for the International Material Data System, the ASTM D4000. So there are several specifications which need to be fulfilled, mainly proposed by the OEM and the tier ones. Then building and construction the same. So here just mentioned the NSF 51 and NSF 61 in North America for water applications. Also then there's a whole range for consumer products, housewares and toys, as well as electrical wire and cable. So we have already mentioned the UL certification. We have also REACH compliance, and also for medical healthcare. There are several specifications which need to be checked and to be fulfilled by the material. Okay, then number 8, actual requirements and load cases. Here it is important for our application to map out the true part functions, all the load cases and the material requirements. And there are requirements like flammability ratings, thermal and electrical properties. They're already specified by the industry standard you're in. As we discussed, for automotive we have, for healthcare we have. And there are other properties, for example the haptic perception, optical properties, which can be more of a qualitative nature. This is what we also already discussed previously. We also have to check the legal aspects, then the way we manufacture the part, and what we also already discussed, the cost level. And by the end, after collecting all this, we have to rank also and make a property prioritization, so that we know, okay, this need to be fulfilled, and this is a nice to have to be fulfilled. Then number 9, prototype testing. So when we have then a material selected and we want to test if it is really suitable for this kind of application, we need to start prototype testing, create the prototype and test it. This can take from days up to months, and it can be a basic testing by tensile bars and plates, or a complete component and system testing. And so here it is important to build up also a network of prototype builders who can supply you with fast prototypes, either injection molded or 3D printed. Also important is to consider the virtual domain using filling studies, and also finite element analysis for checking the mechanical stresses in the part. Okay, and the last point, so point number 10, resin suppliers. So when you selected a certain grade, you also need then resin suppliers who can supply you this grade. And here I collected some tips what to look for at resin suppliers. For example, one point is the broad product portfolio. So it's better to seek out for a supplier who has a broad portfolio, because then he has a more resin neutral approach and can really tailor you the best polymer chemistry for your application. Also the customer interactions. So suppliers need to ask the right questions, because it's also their job to translate product requirements into material requirements and then help you with the material proposal. Then technical support is essential here. So material suppliers should have a technical staff which can support the customer from ideation to commercialization and beyond that. So it's really full service approach. Then in-house regulatory teams. We have already touched on this topic today. So it's nowadays the opinion that a regulatory team is a must-have to keep even up with all the changes happening on a global scale. And here is an important point to watch for. And also a global and local to local supply. So basically to when you are in a company which is globally active and you have operations in Asia, America and Europe, you need a material supplier who can supply the same grade globally in the same quality and have also local sales and technical support, so to really help you then with issues on site. Okay. If you want to get more information on different polymer engineering topics, I recommend you my blog findoutaboutplastics.com. As well, in terms of material selection, I created 2 selection courses on Thinkific, one general polymer material selection course and one on electric vehicles. I will link you both the blog and the online courses in the description below. Okay. I would like to thank you for watching and do not forget to subscribe and smash that like button. Till next time and bye.